Welcome. Thank you so much for joining me today, James. I really appreciate you giving your time to us. And for those of you listening, I'm sitting down in Flavia from Southeast London Community Energy, and I'm having a conversation with James Foster of Foster and Perpatidou, a local architecture firm that have done some really exciting things around retrofit in conservation areas, as well as leaning into passive house standards. So welcome, James. Thanks so much for giving your time to us today.
Thank you. It's good to talk to you. So we are Foster Perpatidou. We're a Southeast London-based practice. We're in Brockley. My partner's been running an office locally since 2012, and we joined forces 3 years ago and established Foster Perpatidou to focus on projects that interested us. And that was after sort of 20 years of working in commercial practice. So I've worked for some good designers, Richard Rogers, Ron Arad, Chrysanthe's worked for Zaha Hadid. So we've sort of been at the creative end of things, but we wanted to focus on things that interested us. So over those 20 years, I was able to work on some really interesting stuff. Museums, hotels, modular housing, social housing. But sort of the one that's most relevant to this talk about conservation areas and retrofit was completed earlier this year, and it's a refurbishment and renovation of a Grade 2 listed library for Exeter College in Oxford, and it was designed by George Gilbert Scott, and it sits against the renowned Grade 1 listed Bodleian Library, which you can see on the very right-hand side of the right-hand photograph. So super prestigious project, and we had to be very sensitive with the way that we did that refurbishment. And one of the key drivers was to make energy savings. So the work included new insulated roofs, new insulated limecrete floor slab, new roof lights to improve daylighting, completely new heating and electrical system, LED light fittings, and a lift to make the building fully accessible with minimum visual impact. So as you can imagine, putting a lift in a building like this without compromising the integrity of the building was a challenge. So when we work, we like to use natural materials. We like to think about energy conservation and about well-being and about integration with landscape. My partner qualified as a passive house designer, certified passive house designer in 2022. And off the back of that, we met some great local clients, and they commissioned us to design a passive house for a site in Brockley, in the Brockley Conservation Area. So we've designed a 3-story passive house, and after a lengthy but positive process with the Lewisham planning team and the Brockley Society, we secured planning approval at the end of last year. So we're now working up the detailed design towards construction. So obviously it's a new build house, not a retrofit, so it doesn't quite meet the brief for this talk. But it's relevant because it's focused on energy performance, energy conservation and comfort for the occupants. The other sort of relevant side of things is the planning process in the conservation area. We were in the curtilage of a listed building, we're in a conservation area, and we're well practiced at these conversations. And we found that the planners are becoming increasingly more interested in doing the right thing in terms of energy performance. Passive house principles are about making the best use of passive influences, the sun, shading, ventilation. Now, in the case of an existing building, we obviously can't move it or turn it to face south. So in a retrofit, we look at the building fabric as a way to deliver energy efficiency improvements. And the principles, the passive house principles that we can apply, far greater insulation than typical projects, triple glazing with insulated frames, air tightness levels, improved air tightness levels, A passive house is sort of 20 times more than a standard build, and a mechanical ventilation system with heat recovery. Existing properties, there's a standard called Retrofit. If passive house is the gold standard of new build, then Retrofit is the gold standard of retrofit, and it uses the same ingredients: high levels of insulation, triple glazed windows, high levels of air tightness, and mechanical ventilation and heat recovery. In a way, it's tougher dealing with the irregularities of existing fabric. And there are other certifications out there, such as the AECB Carbon Light Standard. Now, it's all sort of wonderfully geeky and technical, and you have to fill out sort of pages and pages of Excel spreadsheets as part of your passive house planning package. And the whole team have to be committed to compiling and adjusting this data. So there's time that goes with achieving this, and it's not for everyone, and it's not for all projects. Sort of speaking to clients, retrofit clients from the outset about projects, we meet a lot of clients who have other priorities. Our house is pretty warm, we need to be in by July is the usual sort of priority. We're in a hurry, we don't have the budget, but there's always a budget for a good kitchen. So we found with some projects there are ways to introduce these concepts without it becoming the primary focus. So, for example, this project the brief was for a full width extension with big glass sliding doors, working with what was to be a very special garden. So it was never going to be the most energy efficient project because we've got lots of glass. But we felt like a minimal, simple extension was the right approach for this house. And so we set about designing an envelope that would make up for the heat losses through the glass. So this is a timber frame project. We're trying to use as little steel as possible. We've got pad foundations and ground beams rather than a big heavy concrete slab, so less concrete. The timber frame allows us to pack it full of thermal insulation, so we get the highest energy performance. And then a green roof tops off the extension, which helps to mitigate overheating in the summer, and a pair of roof lights sort of scoop light deeper into the house. So this is sort of energy conscious retrofit by stealth in a way. The exposed timber grid supports the roof and it adds shade to the roof lights. And the green roof also gives a great outlook from the landing window. And the garden has come on a bit since this photo.
Can I just stop you before we go on to PV? Because I feel like that opens up a new can of worms, and I've already got quite a few questions based on what we've been chatting about. So what I was wondering, James, was you talked about the relationship with the planning officers when getting that new build through, but I guess also for the retrofit project that you've spoken about, both in Broccoli. What were the key questions that you were asked, and what were the key barriers that you needed to overcome, and how did you find the creative solutions to move forward together?
A lot of it is about other people's amenity. So a lot of it is about carefully demonstrating that you're not affecting other people's amenity. So okay. Heights near boundaries, angles of views from windows. For the passive house project, we had to do a daylight and sunlight model to show that we didn't impact other people's daylight levels. So questions about that are sort of key that we need to answer from the planners. Yeah, I think that's the main one. And then obviously materiality that we have to address, and sometimes that comes down to planning conditions as well. So we will have sample boards for the passive house on site for the planners to look at before we go ahead with the full final build as a condition. So yeah, a lot about materials, a lot about amenity. And then key questions relating to energy use are about things like air source heat pumps, making sure that they're not going to affect other people's amenity noise-wise. So we have to demonstrate that with technical data to back up the noise levels, the acoustic levels.
And then just to follow on with that, with the new build, it does look to be aesthetically quite different from what's usually within a conservation area. Still with some sensitivity, because I've noticed that the way that you've kind of divided the house just kind of reflects the lines that you would usually find also within the area, not necessarily the shape, but just it feels like there's some continuity in terms of points of visual reference. How did you address those kind of aesthetic considerations that come along with working in a planning area or a conservation area?
So with this project, although the materials are quite different to the existing context, it's really locked in to what's there already. And that there's a house called the Carriage House, which is next door, which was the carriage house associated with the same grade 2 listed villa as our plot. And the planners had a lot of value for this carriage house. It's quite a nice addition. It can be seen from the main road. And so we've responded to the scale of the carriage house. We've responded to the sort of gabled profile. We have the same kind of elevation to the mews as the carriage house. So that sort of defined our 2-story element. And then the single story element is lower. You can't see it from the street. And so that allows us to sort of use more of the site in a more efficient way without changing the view from the street. So it is kind of locked in its geometry. So yeah, that was the logic behind the massing. And then there's a basement level in this project, so the landscape has been sculpted to sort of bring light into the basement. And then from a passive house point of view, glazing facing south with shading, so the roof canopy extending over those windows.
Great. Just for nomenclature, because you said massing. When you say massing, what do you mean?
I guess some of the first things that we do when we design a new building is we look 3-dimensionally at volumes. So it's about the volumes, it's about the shapes, it's about boxes, stacking boxes and shapes on site, and then carving into them. We might start with a physical model. We often start with a physical model and sort of building up boxes and then carving away at them to keep views and to align with other things, other buildings usually, and to respond. The other key thing on this site is a big oak tree, which we had to respond to by keeping out of the root protection area for this oak tree. So that informed some of the shapes, some of the geometry. So we feed all of these things in, and that generates a massing, which then becomes the building.
Okay, cool. Yeah, nice. It's nice to it's a really beautiful way of understanding how a building can be built. It makes me think of, this is a complete tangent, but do you know Barbara Hepworth? She sculpted from truth to materials. So she started with a big slab of stone, and then she would see what the stone wanted to reveal to her, and in doing so would honor the material she was working with. And it feels like you've got a very similar approach, which is quite poetic. But now back to the practical. PV in conservation areas is definitely like a point of contention primarily because of, our need to create distributed energy systems, to remove pressure from the national grid, but also to ensure that we have local clean green energy supply. And conservation areas are quite limited in terms of where you can be making changes and the visibility of those changes. And even though, the only roof which is south facing may be the front facing roof, and therefore it rules PV out for those houses. It'd be really great to hear from you how you've kind of come up against PV in conservation areas as well.
Yeah, I think we found this is an image from last month of PVs being fitted to York Minster. So I think if they can do it in a World Heritage Site in York Minster, then surely there should be a way of doing it in conservation areas without harming the existing fabric. These are more images from some new projects, a stonemasonry centre in the grounds of York Minster, which I was involved with Tonkin Liu Architects. I was assisting them with some technical design of the timber frames. And these buildings integrate PV in clever ways. The left-hand image uses flexible PVs on a curved roof, and the right-hand image, the right-hand two images, sort of tuck the PVs in below a parapet wall, and you can see on the right-hand image the city walls in the background. So we're sort of in super sensitive location. So with a bit of clever thinking, there are ways to integrate PV. This was a study for a house in the Brockley Conservation Area. The house faces south, so textbook positioning for PV was on the front facade. Planning officers advised that they were acceptable. There's a carbon reduction, which is a benefit to everyone. So that would outweigh the impact on the existing building. And it would be less effective to place them on the north, on the rear slope. So we had to do an application, and we set out the panels on the top roof to avoid visibility from the street. Obviously, the ones on the front slope, you can't avoid visibility from the street. Now, our preference would be for something integrated, so something inset into the roof finishes. And in this case, the client would have gone for that. But it wasn't, the conservation area weren't overly enthusiastic about any PV on the south face. The planners didn't stipulate roof integrated solar, and so the result was surface mounted panels. But that's not something that the conservation area are very happy with, and I think that it would be good to work with them and with Lewisham planners to find solutions that everybody feels are appropriate. And from our point of view, solar slates or roof integrated recessed PV is appropriate for a conservation area.
Can I just step in with a quick question? Because I know I've had solar, I've lived on a boat, I've had like kind of flexible PV put on, and we sprung for the flexible PV because we didn't want to have to worry about wind uplift, actually, if we happen to be there to be in a moment of storm on the boat. And so usually the panels will be mounted with brackets onto the roof, and that can run into quite a few thousand of pounds. So I was just wondering, in terms of the price differential, roughly, when you're looking at integrated roof panels like this, how much more expensive is that than your traditional PV? We can talk in 3 times, 4 times, rather than putting exact figures on it as well, just because the prices are changing so much.
Yeah, I don't have any numbers, unfortunately, but I think a lot of it depends on your roofer, because I think the surface mounted PVs can be installed by PV companies without disturbing the roof finishes, and that's their appeal. You don't need a roofer. you need a PV company who can sort of clip it on the top, if you like. Whereas the integrated solutions, you're taking away your roof finishes and you're replacing them with something else. So they are going to be more expensive. But the result you get is something that feels like it's part of the building. And I think for projects in a sensitive location, they feel like a good solution.
Thanks. I realize I put you on the spot there, but I think they are quite beautiful. You know, they do make that little bit of difference.
So moving on from PVs, which there's sort of a lot of schools of thought about sort of the pyramid of energy implementation. It suggests that you should start with good, efficient fabric, and then you should change the tech, change the heating system, energy efficient appliances, and then the PVs should be the sort of the last thing, the sort of additions that you add on. We have, this is a different conservation area. This is the Sloane Stanley Conservation Area in Chelsea, and this is a little artist studio project, which is an ongoing project. So we haven't started building it. We've got planning, and we're sort of, again, detailed design, talking to contractors. And so our site is the annex to the left of the main hall. And the first approach with the planners was to say, let's rebuild the front facade. It's clearly in poor condition. It's a bit, let's say, quirky in its geometry, and it doesn't have the sort of formality of the main hall to the right. So that was our initial approach. And then internally, we've got a big artist's north light, bringing in light, and the glazing is great for the quality of light in the space, but it's hopeless thermally. And it shows that sort of the poor condition. The image on the right shows the poor condition of the facade as it turns the corner with a sort of weird little dormer that's been added at some point. So we were trying to rationalize all of this. And here we made models, we studied various options. We had pre-application meetings with conservation officers and with planning officers, for which the models were very useful. The conservation officer in Kensington and Chelsea was very enthusiastic about preserving the artist studios, the few artist studios that are left in the area. And so we had to work with her to find a balance to the front facade. The first option is the sort of top left of those 4 images, which was very much to square it off and wrap the facade round. Where we ended up was with something that the sort of image on its own on the left, which is keeping the features of the sort of curve and the geometry of the existing facade a lot more. So basically, we're keeping the exterior as it was, which pushes all of our energy related interventions to the inside. And then beyond the facade, where we're changing the roof, we're inserting a couple of new dormers on the right hand side of this roof, and that allows us to add 2 new mezzanines internally and just get a bit more floor area and make the space work a little bit better inside. So facade wise, this is what we're aiming for. So hopefully we're keeping the charm of what's there. We're cleaning it up. We're creating a new garden wall, which echoes the curve on the facade. And so then going to this fabric first principle, it's then what do we do internally? We insulate it, but that means ventilating the space so that we avoid the risk of condensation. That means minimizing that risk of condensation, so we have to be careful with materials. So that suggests an approach to materials using natural materials. So we're looking at wood fiber and lime plaster as the sort of primary materials for the internal insulation. So something that works with the original Victorian fabric and avoids trapping condensation which is a big risk with things like Celotex and Kingspan, sort of oil-based insulations. So we're then reworking the facade on the other side at high level with the two new dormers, and here we'll rebuild the walls in insulated timber frame, a bit like the big extension in Brockley. So insulated timber frame here, pack as much insulation in as we can get, and we sort of running through the different fabric build-ups for this property, and then we've made some sort of careful diagrams about the bits of the facade that we're changing. So the yellow is the bits that we're sort of cutting away at and removing, but very careful to preserve what the character of what's there. So a couple more sort of lime, plaster, and wood fiber images, and the MVHR is sort of key to making this work. And in this case, we're looking at a decentralized MVHR system. So basically, extraction with heat recovery, but not all connected together with physical ducts like you would with a sort of standard MVHR system. These things talk to each other electronically, but they don't connect to each other physically. So there'd be extracts in the kitchen and bathroom, and then supplies in the living spaces, and the heat from the extracts would be recovered.
Just for those of you who are listening who don't know what MVHR is, it's mechanical ventilation with heat recovery, and there's different modes, different styles of systems that you can have. One is kind of like a connected up system that works throughout the house, which requires ducts, as James says, and then you can have individual units that are capable of doing it, that do talk to each other, and they recover heat. So that heat isn't lost out of the building through the extraction system, but pushes it. The heat that would usually be pushed out is then recirculated, so that the building retains more of its warmth. Jump in if there's anything I've forgotten in that explanation about mechanical ventilation with heat recovery.
No, I think that's good. I think that the decentralized systems are sort of new ground for us. So that there's a little bit of testing to see how will it perform in comparison to the ducted systems. So yeah, we're looking at new things to have less impact, but still give us that performance. Moving on to another project, which is technically not in a conservation area, it's virtually in a conservation area. It's on the edge of a conservation area in Blackheath, and this is a 1970s townhouse. And we are looking at interventions such as external wall insulation. Where else can we get insulation onto this house to make it perform better? There's a lot of glass on the front facade, so we're looking at just limited areas on the front facade that we can add more insulation to. So we're currently going through a sort of quotation stage, looking at how much does it cost to get external wall insulation, how much more does it cost to have brick slips versus render. So brick slips are very thin slices of brick that would be applied, that would be bonded to the outside of the external wall insulation, so that at the end of the work, you can't see the difference. The alternative is to render over the insulation, and so once we've got a handle on costs, we'll then go to the planners with an approach and have that conversation. So also in this house, it's about looking for opportunities to install things like MVHR. It's looking through the house, understanding the house, really understanding where are all the voids and the spaces and the opportunities to move air around using MVHR systems. So this is sort of currently under development at the moment, and ultimately the decision will be whether we have a ducted MVHR system or a decentralized MVHR system, and that will depend on the number of ducts and the available space and the routing. And so that's something that we'll work together with MVHR installers to sort of find the best solution. And then moving on to another little project back in Brockley. This is a little dormer project, so you'll see a very small isolated dormer here, and we're proposing to upgrade that dormer to something which will improve the quality of space up there in the top floor. So that's the main move here, is to sort of get rid of something dilapidated and replace it with something that really makes the space, improves the space. But also this is an opportunity to get fabric improvements. This building's complicated in that it's over 11 meters from the lowest ground level, which gives us new rules, fire-related rules, about non-combustible materials. So not the windows, but any cladding has to be non-combustible. And the planners were, so we've got planning for this. The planners wanted us to make sure that there was no element of this dormer that was higher than the existing roof. So that was a limitation, and that was a challenge internally. We've got 2 meters of headroom, so on the other side of things, we can't go less than 2 meters. So there's a conflict here between like making fabric improvements, making things thicker, and not exceeding the planning limitations. So this one has, we've got planning permission. We're now talking to the planners again about factoring in these thicker build-ups to make the performance better, and they recognize the drivers for this, and so hopefully they'll allow us to make a material amendment to sort of thicken things up and get this thing working better. So I think there's a positive direction of travel, more joined up thinking between planning, between energy efficiency, and maybe changing some of the sort of set in stone planning rules about things like heights to allow it to be easier to make these fabric improvements. And that's where I finish, from the green roof.
Excellent. I have questions for you, James. It's nice to end with a picture of greenery so that our eyes can rest on it. So a lot of the questions around conservation areas are about what's happening outside of the house and maintaining that kind of aesthetic respect outside for the street-facing facade. And I've noticed that in your work you have a real sensitivity to balancing out kind of the history, as well as like the history of the building, that historical aesthetic, as well as bringing in new materials and modern design styles. And so my question for you is for people who do live in conservation areas, or who see themselves as kind of custodians of an older house and kind of respect that they can't just knock things down willy-nilly, and kind of have that reverence for the built environment. When working in a conservation area, a lot of the changes will have to be happening to the fabric indoors, and that'll mean that, for example, with all the molding, that's a question of how that's addressed with to be putting in fabric changes, and I guess without just kind of seeking to replicate the same structure that is there now and just making it in a smaller frame. How would you kind of, when looking at a space, I guess I'm looking for some pointers around sensitivity that kind of bridges modernity as well as that kind of historicity of houses, and just to hear some of your thoughts and reflections on that.
I mean, I've got an image in my head of a space that we've worked with, and we've not quite had the courage to improve it yet, but in terms of thermal performance. But it's a Victorian house, beautiful brick walls externally. It's in a conservation area, beautiful cornicing internally. So what do you do? I think the starting point is the windows, because you've got big sash windows, very drafty sash windows, which can be replaced with double or triple glazed sash windows with better seals. So you're sort of improving the air tightness, you're improving the sort of internal surface temperatures of the glass, you're reducing the condensation. So that could be one intervention which doesn't really change the character, which is what you're trying to avoid in a space like this. There's something that we'd like to try. There's a technology that we'd like to try using plaster. There's a product called diathanite, which is a plaster which is a mix of lime and cork, and it's an insulating plaster, and it's breathable. And that can provide improvements in the thermal performance of your external walls. If it replaces the existing plaster, then it can do that without making the walls any thicker. So this is something that we haven't put into practice yet, but we would like to try that. Yeah, the theory being that you can improve your walls without taking away the coving, without taking away the cornicing, and without changing the outside. So lots of potential there.
We're doing an eco home tour in February, and they've used cork sole on their home, and the owners, Anna and Sheila, rave about it. So I think it's a similar product, isn't it? Yeah, it's a render on the surface. So it's a nice, gentle, subtle way of making that difference. And I have a wall earmarked in my house that I'd like to have a play with it on as well. Great. Okay, I think that's all the questions that I have in my brain that have come out of this conversation. Thank you so much for your time, James. I really appreciate it. Just to hear about all the awesome things that you're up to. Please do keep us up to date. And thank you so much for your time. Really appreciate it.
Thank you.